We're going to look at some examples of Dalton's law. In this first example, we've got a container with three gases, oxygen, carbon dioxide, and helium, with pressures of 2, 3, and 4 atmospheres respectively. And we'd like to know the total pressure inside the container. With Dalton's law, it states that the total pressure is equal to the sum of the individual partial pressures, and therefore we simply need to add up the three individual partial pressures, and we are left with 9 atmospheres. In example 2, we've got a mixture that contains hydrogen, helium, neon, and argon. And this time we're given that the total pressure is 93.6 kilopascals, and we're given the partial pressures of helium, neon, and argon. We would like to know what pressure is exerted by the hydrogen. So again, Dalton's law applies here. So the sum of the individual partial pressures is going to equal the total pressure. And so we simply need to sub in all of the values we've been given and solve for the partial pressure of hydrogen. And in this case, it's 16.9 kilopascals. This third example, we're going to work with a visual. So we've got 3 samples of gases. We've got helium, which is represented by the yellow gas, and nitrogen, which is represented by this diatomic gas that's blue. And we want to rank these 3 containers that are at the same temperature from lowest to highest. So the first thing we want to do is look at the total pressure. The pressure, remember, is going to be proportional to the number of moles. Because when we look at PV is equal to nRT, our V and our R and our T are all constant for these 3 gases. So we're at the same temperature, our volume is the same size, and R is a constant. So what we're left with is a relationship between the number of particles of gas and the pressure. So what we need to do if we want to rank them based on the total pressure is compare the number of molecules. So we have 1, 2, 3, 4, 5, 6, 7. We have 4. And we also have 7 here. Okay. So when we want to put them in order of total pressure, this one is going to be the lowest, and then these ones are going to have equal total pressure. And don't be fooled by the fact that the nitrogen looks like it's bigger. Individual gas molecules, we have to remember, the identity of them does not impact the pressure that they will exert. It's just the number of particles that we have. For the partial pressure of helium, what we need to do is just count up the yellow ones. So this container here, number 3, has the fewest helium, container 2 has the next, and container 1 has the most. For the average kinetic energy of the particles, that's going to be the same for all of the containers because, as we know, it is the temperature that is proportional to the average kinetic energy.